My project title is Role of Ants in Modifying Soil Chemistry, and myself as Lokeshwaran and my partner A. Shabir under the guidelines of Mr. M. Chandran, Head of the Department of Biotechnology. Aim to emphasize the importance of ants in modifying soil chemistry, and objective the role of ants in heavy metal pollution. In our study, body metal concentration were determined in samples collected from polluted and unpolluted sites. These concentration were compared with metal content of soil at the same sampling sites. The objective of this study were to soil modification created by ants. Materials and methods. First one, ant farm experiment. Approximately 7 centimeter of soil was distributed on plastic tray covered with glass plates. A controlled soil collected from Tiruvethur 5 km away from Manali was distributed on another tray. Glass plates prevented ants from escaping from the ant farm. One large ant colony was added to each treatment ant farm, since the goal of this experiment was to test how two ants were responsible for polluted soil and controlled soil, if the ants were reduced heavy metal concentration or not. Field study. First one is sampling. To obtain sample from sites with different metal availability. Camponotus ants and soil material were collected from near Manali. The second location include residential area, Tiruvethur, 5 km away from Manali, with mostly automobile traffic and municipal waste. Soil sample were collected from randomly selected nest and the control soil 5 meter away from the nest at near radials. Ants were placed in plastic vials and stored at minus 20 degrees Celsius until analysis. Soil sample were stored at room temperature in sealed plastic bags. Chemical analysis. Chemical analysis was performed to quantify the metal content of whole ant bodies. Ants were first cleaned by washing with double distilled water and then oven dried at 60 degrees Celsius for 24 hours. Metal content was determined by digesting oven dried material in 5 ml nitric acid at 80 degrees Celsius until digesting, after which 2 ml of perchloric acid was added to and the volume adjusted to 10 ml with deionized water. Soil samples were dried 60 degrees Celsius for 24 hours and then milled and sieved through 2 mm stainless steel mesh. Dissolution was carried out in 50 ml Erlenmeyer flask using 0.5 gram of sample and mixture of 5 ml 65% nitric acid and 50 ml of 37% hydrochloric acid. The solution was heated at 50 degrees Celsius in sand bath for 4 hours. Centrifuge, filtered and diluted to 100 ml with deionized water. The concentration of the element was performed using an atomic absorption spectrophotometer. Results. Field study. Ants accumulate high concentration of metal both in polluted and unpolluted areas. Metal body concentration in ants originating from polluted areas are higher than in ants from unpolluted areas. When comparing ant and soil metal content, the concentration within componentous bodies was always significantly correlated with the amount in the soil. Amounts of zinc and cadmium in ants were higher than in the soil. Soil parameters, nest versus control. The nest soil was significantly different from the soil of control plots in the chemical parameters. There were greater concentration of available phosphorus and potassium as well as organic matter, magnesium and sulfur in the nest soil. In contrast, the soil from control plot had more nitrogen, calcium and sodium. Similarly, saturation mm, potassium and saturation magnesium is high and saturation calcium, saturation sodium is low in the nest soil. Nutrient concentration were also significantly different between the successive soil segments. And also heavy metal concentration of nest soil, zinc and manganese, uh, iron, copper is high when compared to control soil except boron. Ant activity lowered soil pH in alkaline soil nest and increased soil pH in acidic soil nest. Our experiment on newer studies could, however, only confirm this for alkaline soil. The pH is reduced in nest soil compared to control soils. The electrical conductivity and CEC, cation exchanging capacity, is high in nest soil. And finally, conclusion. and poses several features that make them good candidates as indicator of environmental contamination. Ants are considered useful for biomonitoring studies as they can respond to environmental changes. Zinc and cadmium clearly accumulated within the ant body with respect to soil concentration, and also the pH is controlled. Our experiment clearly shows that ants are responsible for changes in soil pH and phosphorus and potassium concentration. Our experiment confirmed that ants are able to modify soil chemical properties. Thank you.